do have this beautiful medallion, a seal of the university, and on the face it's inscribed Alumni Endowed Professorship in Pediatrics, and on the reverse, Robert O. Heuckeroth, MD, PhD, October 30th, 2012. Congratulations on your appointment.
That's really what all of us want, is to have healthy children. And so my interest in birth defect prevention comes from this little bit of data. Birth defects are now the leading cause of infant mortality, accounting for about 20% of neonatal deaths. And when you take care of kids in the hospital, we see kids all the time who are in the hospital because they had some major part of their body that did not form correctly. Roughly 3% of all children in the United States have some major birth defect, including really commonly heart defects, Down syndrome, a little less commonly spina bifida, and this particular disease, Hirschsprung's disease, that I'll tell you about in more detail. This is a relatively simplistic view of birth defects, and this is what I learned in elementary school. Birth defects occur because of some defined genetic risk and some environmental risk. In this case, environmental risks refer to the fetal environment, so it's maternal health, maternal nutrition, medicines, toxins, infections, and you could probably add to this list. And there are some birth defects that may occur purely as a result of environmental exposures, and some that occur purely as a result of genetic risk, and then many where there are contributions from both environmental and genetic risk factors. And Hirschsprung's disease is a problem that happens in about 1 in 5,000 babies. It's a problem where the nervous system that is supposed to be within the bowel all the way along the length of the bowel is missing at the end of the bowel. It causes incredible abdominal distension, bilious vomiting, severe chronic constipation. Even after surgical correction, a third of the kids continue to have serious life-threatening episodes of bowel inflammation that we call enterocolitis. The death rate, the most recent death rates for Hirschsprung's disease are still about 5%. And many of the children with Hirschsprung's disease have other serious medical problems, in part because the neural crest gives rise to other structures, including, this is actually a beautiful picture of green great vessels coming out of the heart. These are neural crest-derived vessels. All right, so the enteric nervous system forms from two main populations of cells. It forms from vagal crest and sacral crest. Most of the cells come from the vagal part of the neural tube. They migrate into the bowel and down the bowel all the way from one end to the other. As far as I can tell, this is the longest migratory route of any cell population known. The cells to populate the bowel have to divide like crazy and then differentiate into neurons and glia. And we can study them in many ways, including in a dish. You can take a little piece of the bowel, and these green cells are actually expressing a fluorescent protein, and you can watch the cells migrate across the dish, and you can stain them when you're done and ask questions about how do those cells manage to migrate so quickly? How do the cells migrate? How do they know where to go? And I think an important issue for Hirschsprung's disease is that anything that will slow those cells down increases the risk that the end of the bowel will be aganglionic, will be missing nerve cells, and that the kids will have Hirschsprung's disease. All right. Whoa, enough of that. All right, so when I started studying this, there's actually nothing known about the molecular mechanisms that control the enteric nervous system development. This slide I stopped adding to about 5 years ago because it got too busy already, but what you can see is that there's this RET transmembrane tyrosine kinase, there are RET co-receptors, there are RET ligands, there are other trophic factor receptors and their ligands. There are a series of transcription factors, there are cell adhesion molecules, there are intracellular signaling molecules, there are a variety of morphogens that all control different aspects of enteric nervous system development. And if you look at the genetics of Hirschsprung's disease, many of the molecules that cause Hirschsprung's disease in people when they're mutated actually can be tied back to RET. So RET, when it's activated by GDNF, stimulates a variety of intracellular signaling molecules that encourage cell proliferation, survival, migration, axon extension, cell polarity, cell polarization needed for efficient migration. And mutations, these are transcription factors, mutations in SOX10 and FOX2B Both cause Hirschsprung's disease, syndromic forms of Hirschsprung's disease in humans, which is, I think, how you end up with giant lists like this. So this is a summary of some of the human genetics of Hirschsprung's disease. I think you can see it's incredibly complicated. And I'll just point out a couple of things. So Hirschsprung's disease occurs in about 1 in 5,000 children. Half of the people that have Hirschsprung's disease who have another affected family member will have a single allele of Rett inactivated. And having a single allele of Rett inactivated, so meaning one good copy, one bad copy, increases your risk roughly 2,500-fold. So if you have a single copy of Rett that's inactive, your risk of Hirschsprung's disease, instead of being 1 in 5,000, is 1 in 2. And I think the question is, what is it that determines whether you're in the 1 in 2 that has disease or the 1 in 2 that doesn't have disease? And some of that is gene-gene interaction, and some of it may be gene-environment interaction. And I think here you can also see a common mutation. Down syndrome increases your risk of Hirschsprung's disease 50-fold. So it's roughly 1 in 100 kids with Down syndrome will have Hirschsprung's disease. What is it that determines whether you're one of the 99 that doesn't or the one kid out of 100 that does? All right, and that, I think, raises this question: can Hirschsprung's disease be prevented? And I think perhaps in some cases it can.